Hello viewers. If you're a techie working in IT focused on infrastructure, operations, systems administration, Azure administration, or even if you're on the business side, meaning you're not a developer, you do want to be conversant with DevOps practices to excel in your job role while supporting your organization's DevOps initiatives. DevOps is not for developers alone. Part of it is highly applicable to others in IT. And in this session, I'll explain why and how, and we'll also learn essential DevOps concepts pertaining to Azure that you, a non-coder, must know. I am Sucheta, the creator and presenter of this session that I've put together as part of the 90 Days of DevOps event of 2024. Listed here are a couple links where you can explore more about the 90 Days of DevOps initiative and all the other technical content that is being shared as part of the event. Some information about me. I'm a manager in healthcare IT with a focus on endpoint engineering. I specialize in modern management and enterprise mobility, leveraging Azure and Microsoft Endpoint Configuration Manager. I'm a 12 times Microsoft certified professional who likes learning tech and collaborating for knowledge sharing with tech enthusiasts. This is the agenda for what you'll learn here. I'll start with a high-level overview of DevOps, including what it means in context of things you do in Azure, why organizations practice DevOps, and how it helps. We'll also understand an application lifecycle in context of DevOps and learn about the DevOps culture. Then we'll delve into what is Azure DevOps and subsequently learn how non-coders can harness the capabilities of Azure DevOps. I'll continue from there to walk you through explaining the specifics of individual DevOps practices, starting with CI/CD, into version control and Agile, and so on. While we look into each of these DevOps practices, I'll highlight how non-coders can leverage each of these practices. Lastly, we'll discuss what you can do next with the understanding gained in this session. So let's get started with the foundational DevOps concepts, beginning with what DevOps is. The contraction of Dev and Ops refers to DevOps, which is mainly a software development practice that promotes collaboration between siloed development and operations functions, resulting in faster and more reliable software delivery. Providing a comprehensive framework to develop and release software, DevOps connects development and operations teams, a gap that can create challenges and inefficiencies in software delivery that is with the traditional approach. Commonly referred to as a culture, DevOps connects people, process, and technology to deliver continuous value. The idea is to create multidisciplinary teams that work together with shared and efficient practices and tools. Essential DevOps practices include agile planning, continuous integration, continuous delivery, and monitoring of applications. DevOps is a constant journey, as you would notice from the figure on the slide. By adopting a DevOps culture along with DevOps practices and tools, teams gain the ability to better respond to customer needs, increase confidence in the applications they build, and achieve business goals faster. DevOps can be practiced across various capacities and projects in an organization, including business, IT, and infrastructure initiatives, wherein we design and implement infrastructure strategies that allow continuous integration, testing, delivery, monitoring, and feedback. Leveraging DevOps in an IT project execution streamlines delivery by optimizing practices, improving communications and collaboration, and creating automation. DevOps experts develop and put into action DevOps methodologies and techniques related to, say, version control, infrastructure as code, etc., by leveraging Azure. We'll delve more into the context of Azure in DevOps as we move along here. Let's look into the benefits of DevOps. Teams that adopt DevOps culture, practices, and tools exhibit improved collaboration and productivity, which is integral to achieving business goals such as accelerating time to market for a product, adapting to the market and competition, maintaining system stability and reliability, and improving the mean time to recovery. DevOps focuses on delivering continuous customer value through agile release cycles and feedback-driven improvements. It emphasizes automation to minimize errors. This encourages end-to-end responsibility, bridging the traditional gap between development and operations, thereby streamlining the software delivery process. Connecting development and operations leads to an increased visibility, more accurate requirements, improved communication, and faster time to market. Here is just some of what you can do with Azure and benefit from DevOps practices. Automate app deployment with continuous integration and continuous deployment. Deploy to the web apps feature of the app service, Azure Virtual Machines, Service Fabric, or Azure Kubernetes Service. Take advantage of granular performance monitoring, alerts, and easy-to-consume dashboards to help ensure your applications are available and performing as you expect. Invest less time integrating and more time building solutions. Azure integrates with the popular open source and third-party tools such as Jenkins, Terraform, and Ansible. In a nutshell, DevOps helps improve the software delivery process. Now we dive into the application lifecycle and the role of DevOps and Azure. You can leverage DevOps tools for every phase of an application's lifecycle. Applying the right combination of DevOps technologies, culture, and processes enables continual software delivery. You would use Azure to implement DevOps practices throughout an application's phases, namely planning, development, delivery, and operations. Each phase relies on the others, and the phases are not role-specific. In a true DevOps culture, each role is involved in each phase to some extent. Let's review each of these phases. Plan. In the planning phase, DevOps teams brainstorm and outline the features of their applications and systems. They monitor progress across various levels, from individual tasks to multi-product portfolios. Techniques like creating backlogs, bug tracking, managing agile development with Scrum, employing Kanban boards, and using dashboards ensure agile and transparent planning. Maintain clear and timely development progress with GitHub and transform data into insights using Power BI's analytical visualizations. Next phase is develop. This phase in DevOps encompasses coding, testing, reviewing, and integrating code, along with building deployable artifacts. Teams aim for rapid innovation without compromising quality or productivity. This is achieved by using efficient tools, automating routine tasks, and employing small iterative updates through automated testing and continuous integration. Accelerate coding with Visual Studio and Visual Studio Code, and collaborate on GitHub. Utilize Azure pipelines for automated testing and continuous integration, and implement automated workflows with GitHub Actions. Bring Jenkins workloads to Azure and swiftly set up developer environments with Azure DevTest Labs, speeding up your application development and market launch. Next phase, deliver. This involves deploying applications to production environments reliably and managing necessary infrastructure. This includes defining a release process with manual approvals and automated gates to transition applications to customer availability. Automation in this phase ensures scalability, consistency, and control, allowing DevOps teams to deliver frequently and confidently. Deploy applications to any Azure service, including Azure Kubernetes, with automation and control for continuous customer value delivery. Use Azure Resource Manager or HashiCorp Terraform to define and initiate cloud environments and establish continuous delivery pipelines with Azure Pipelines or Jenkins. The last one we have here is Operate. This phase focuses on maintaining, monitoring, and fixing applications in production. DevOps teams prioritize system reliability, availability, minimal downtime, security, and governance. They aim to preemptively identify and swiftly resolve issues, requiring comprehensive telemetry, effective alerts, and clear visibility into applications and systems. Achieve monitoring and actionable insights using Azure Monitor for logs and telemetry. Manage your cloud with Azure automation and tools like Ansible and Chef. Maintain compliance in infrastructure and applications with Azure Blueprints or Chef Automate, and enhance security and vulnerability management with Azure Security Center. Next, let's discuss about how to build a DevOps culture. Introducing DevOps to your business means adapting beyond your existing software delivery methods. Developing this new culture is a progressive journey. It's not just about acquiring new tools. It necessitates evolving your team's structure, workflows, and daily practices to fully embrace and effectively implement DevOps. DevOps adoption hinges on cultural and collaborative changes within an organization, leading to the development of high-performing teams. Collaboration, visibility, and alignment. A key feature of a strong DevOps culture is collaboration and visibility among teams, with shared processes, goals, and success metrics aligning development and IT operations. Shifts in scope and accountability. In a unified DevOps approach, teams extend their responsibilities beyond their core roles. Developers focus on both innovation and the stability of their changes in operation, while IT operators integrate governance, security, and compliance early in the planning and development phases. Then we have shorter release cycles. DevOps teams enhance agility and risk management with shorter incremental release cycles, reducing system impact and allowing swift adaptation of customer needs and market changes. Lastly, continuous learning. High-performing DevOps teams adopt a growth mindset, quickly learning from failures to continuously improve, boost customer satisfaction, and enhance innovation and market adaptability. DevOps is an ongoing journey with constant potential for growth. Now let's learn about the specific term Azure DevOps. Now, DevOps, as we know, is the union of people, process, and products to enable continuous delivery of value to your end users. Azure DevOps is a set of services that gives you the tools you need to do just that. These are tools to help you better team collaboration, automate build processes, testing, version control, package management, and so on. With Azure DevOps, you can build, test, and deploy any application either to the cloud or on premises. DevOps practices that enable transparency, cooperation, continuous delivery, and continuous deployment become embedded in your software development lifecycle. Azure DevOps can be integrated with different kinds of work management tools. You can use Azure DevOps to orchestrate third-party tools. So what does Azure DevOps provide? It includes a range of services covering the complete development lifecycle. Azure boards for agile planning, work item tracking, visualization, and reporting. Azure Pipelines is a language platform and a cloud agnostic CI/CD platform supporting containers or Kubernetes. Azure Repos provides cloud-hosted private Git repos. Azure Artifacts provides integrated package management with support for Maven, Python, package feeds from public or private sources. Azure Test Plans provides an integrated planned and exploratory testing solution. Knowledge of Azure DevOps services such as Azure Pipelines, repos, boards, and artifacts is beneficial because understanding how these tools integrate with the Azure ecosystem helps in streamlining the development and deployment processes. Well, what about non-Microsoft or non-.NET focused organizations? The answer is Azure DevOps provides a platform that is flexible, cross-platform, and cloud agnostic. Let's look at what it means by being flexible. You do not have to go all in on Azure DevOps. It is possible to adopt each of the services independently and integrate them with your existing tool chain. Most of the popular tools are supported. Cross-platform. Designed to work with any platform, Linux, macOS, and Windows, or designed to work with any language, including Node.js, Python, Java, PHP, Ruby, C, .NET, Android, and iOS apps. Azure DevOps is not aimed at organizations building and shipping on the Microsoft technology stack. Cloud agnostic, continuous delivery is supported to AWS, GCP, as well as Azure. Now that you have a high-level understanding of DevOps and the context of Azure to it, along with an overview of Azure DevOps, let's delve into the applications of DevOps outside of the software development use case. Non-coders can leverage various DevOps tools and services in Azure to enhance general IT management and operations. Let's look at how Azure DevOps tools and services are valuable for IT folks who are not developers. Non-coders play a crucial role in adopting DevOps practices across various aspects of IT operations. Azure boards. IT teams can use Azure boards to manage and track their infrastructure projects and tasks. It helps in organizing work items, tracking progress, and collaborating on infrastructure-related projects. Azure pipelines. Infrastructure professionals can utilize Azure pipelines to automate the deployment of infrastructure changes. It enables the continuous integration and continuous delivery, that is CI/CD, of infrastructure as code and configuration changes. Azure repos. These can store not only code, but also infrastructure as code templates and configuration scripts. IT infrastructure teams can version control their IAC files and collaborate effectively. Azure artifacts. IT professionals can use Azure artifacts to store and manage artifacts such as packages, binaries, and templates used in their infrastructure provisioning and deployment processes. Azure test plans. While typically associated with software testing, Azure test plans can be adapted for testing infrastructure changes and configurations. It allows for test case management and tracking of infrastructure testing efforts. In summary, these Azure DevOps tools can be adapted and used by IT infrastructure teams to improve collaboration, automate processes, and ensure the reliability and consistency of infrastructure deployments and changes. Azure administrators, not directly involved in development, play a crucial role in a DevOps environment. With the understanding of DevOps tools and services and the DevOps practices, which we'll explore in upcoming slides, Azure administrators can effectively support and contribute to a DevOps culture, ensuring that operations align with the rapid development and deployment cycles characteristic of DevOps practices. Next in this presentation, we'll gain an understanding of the main concepts in a DevOps practice. To actualize DevOps culture, teams implement various practices across the application lifecycle. And as we learn the practices, I'll also shed light along the way for how the understanding of these practices is essential to non-coders, as well as how they can utilize the knowledge in IT infrastructure tasks. Let's start with CI/CD. Continuous integration practice automates code building, testing, and validation for efficient and bug-free code integration. It drives the ongoing merging and testing of code upon completion and commitment, leading to an early finding of defects. Other benefits include less time wasted fighting merge issues and rapid feedback for development teams. The continuous delivery practice means testing and delivering code components promptly, enabled by continuous integration. Such continuous delivery of software solutions to production and testing environments helps organizations quickly fix bugs and respond to ever-changing business requirements. From code to cloud, automate each part of the DevOps process with continuous integration and continuous delivery and your choice of tooling as listed on the slide. Azure pipelines, GitHub Actions, and so on. Notice the text in blue, where I highlight how the practice can be leveraged by non-coders. Having a grasp of CI/CD and its implications on infrastructure, including the deployment and management of applications in Azure environments, is crucial for folks working in IT outside the software development and release functions. CI/CD practice and methodologies can also to some extent be modified and applied to other IT projects. The next DevOps practice we look into is version control. Version control is crucial in DevOps. Usually with a Git-based repository, it enables teams worldwide to communicate effectively during daily development activities. It helps manage and track code changes and allows teams to efficiently develop software by providing file snapshots, enabling easy reversion to any version, and ensuring conflict-free changes. Version control tools enable you to see who made changes, when did they make the changes, and what exactly was changed. Azure Repos is a set of version control tools that you can use to manage code. You can also apply version control within different facets of IT projects other than development. Using version control enables you to keep your scripts and documentation up to date, collaborate with team members, and easily review and revert changes when needed. GitHub provides a platform for managing and tracking changes in various types of files, including documents, text files, and more. By creating a repository on GitHub, you can store your document files and use Git, the underlying version control system, to track changes, collaborate with others, and maintain history of edits and revisions. This allows you to keep documentation up to date and easily review and revert changes when needed. Many organizations use GitHub for managing documentation alongside their software projects. DevOps principles and practices can be leveraged in a low-code, no-code development scenario when using low-code, no-code platforms. With that introduction to GitHub, on the previous slide, let's learn more about GitHub. It is a development platform. GitHub is a Git repository hosting service. You can host and review code, manage projects, and build software alongside other developers from open source to business. GitHub can integrate with other leading tools. GitHub is used for version control. It also provides a range of other services for software development and deployment, such as code spaces, repos, packages, security, and GitHub Actions. Here is what it holds for non-coders. GitHub Actions provides a flexible and extensible platform for creating customized automation workflows for businesses or IT processes. You can automate project management work such as creating tasks, assigning them to team members, tracking progress, and so on. You could also perform inventory and asset management by leveraging GitHub Actions. Moreover, despite being a non-coder, you can still contribute on GitHub. How? You could contribute to the official Microsoft Learn documentation, which is open source and hosted on GitHub. You're allowed to issue pull requests and make corrections or additions to the Microsoft Learn documentation. Find more information about it on the link I have on the slide. Now we are on to reviewing the next DevOps practice, which is Agile. Agile is a term that's used to describe approaches to software development, emphasizing incremental delivery, team collaboration, continual planning, and learning. Agile is not a process as much as it's a philosophy or mindset for planning the work that a team will do. It's based on iterative development and helps a team better plan for and react to the inevitable changes that occur in software development. Adopt agile software development methods with planning, tracking, and reporting for shorter release cycles and full visibility into your software development process. Manage projects with GitHub and use Azure boards to define, assign, and track work items. Manage backlogs. Create custom dashboards to track progress. And get advanced analytics and reporting. Plan Agile with GitHub projects, GitHub project boards, and Azure boards. Agile and Lean methodologies have their roots in software development, but have found applications in IT project management and beyond. Couple other use cases for non-coders are in business process improvement, IT operations, and so on. The next practice we are going to learn about is infrastructure as code, or IAC. This is fundamental to DevOps. IAC brings or helps bridge the gap between development and operations teams by treating infrastructure as code. IAC enables precise management of system resources through code-like definitions, stored and managed in version control systems. Text-based definition files, managed as code, facilitate easy rollback and replication of environments. It enables the automation and validation of the creation and teardown of complex systems and environments to help deliver secure and stable application hosting platforms. Define resources in a descriptive way so that environments are versioned and committed together with application code into repositories. Treating infrastructure as code lets you deploy resources in repeatable and reliable fashion, ensuring cloud environments are fully governed. IAC is effective both on-premises and in the cloud, using automated processes and tools like Terraform or Ansible for declarative infrastructure management. So with infrastructure as code, you manage underlying infrastructure needs for apps, apply IAC principles to define and provision infrastructure resources, for instance, databases, servers, cloud services, and the infrastructure changes are tracked, versioned, and automated. Desired state configuration, that is DSC, is a feature in tools such as Ansible or PowerShell that allows you to define and enforce the desired state of servers and infrastructure components. DSC is a specific component of IAC that focuses on maintaining the desired configuration of servers and infrastructure resources. It ensures that these resources remain in the desired state, which is defined in code. It aligns with DevOps principles by promoting automation, consistency, version control, and integration into CI/CD pipelines, making it an integral part of the DevOps toolchain for managing infrastructure. As for non-coders, familiarity with IAC tools and practices, including ARM, Bicep, Terraform, is important for folks in infrastructure and for Azure administrators. They should understand how to define and manage cloud resources in a programmable and automated manner to be able to spin up or deploy consistent and repeatable setups across environments. Deploying an Azure virtual desktop environment is a good example in this case. IT folks can also use IAC for automating things like golden images, VM templates, to achieve efficiency, consistency, scalability, and manageability in on-premises environments or whether working on the cloud. It's a best practice for modern infrastructure management. Next, we look at configuration management. This DevOps practice enforces desired states, tracks changes, and automates issue resolution. Combined with infrastructure as code, it simplifies managing complex environments. Azure provides tools like Ansible, Chef, Puppet, and Azure Automation. Configuration management principles apply to change and incident management strategies within other IT areas. And so it is beneficial for non-coders to learn and apply the methodology. Configuration management in DevOps is more specific to software delivery and deployment, while ITIL configuration management has a broader organizational scope and aims to support IT service management processes. However, having a generic understanding of configuration management can be helpful to extend the knowledge from DevOps to other IT functions and vice versa. The DevOps practice of continuous monitoring provides real-time visibility into application performance, aiding issue resolution and improvement. The practice enables monitoring and logging of running applications, including production environments, for application health and customer usage. It helps organizations create a hypothesis and quickly validate or disprove strategies. Rich data is captured and stored in various logging formats. You can monitor infrastructure health and integrate into existing dashboards in Grafana, for instance, or the Azure portal with Azure Monitor. You can collect and analyze telemetry data with Azure Monitor. Proficiency in Azure monitoring tools like Azure Monitor and Azure Log Analytics helps admins as they work to ensure the continuous performance and availability of applications and services. This sums up our DevOps practices and an overall DevOps walkthrough in context of Azure, and what non-coders can do with the knowledge in their IT roles. So, for what's next? Now, overall, as we learned throughout the presentation, non-developers who study and practice DevOps concepts can contribute to more efficient, secure, and collaborative IT environments while enhancing their own professional development and career prospects. Thus, taking it further from this session, you could study towards the official certification from Microsoft related to DevOps. This is an expert level certification that's called DevOps Engineer Expert. The main exam you need to pass to obtain the Expert Cert and badge is the AZ400, Designing and Implementing Microsoft DevOps Solutions. But you first need to get past passing one of the prereqs to be able to sit for AZ400. You either pass the Azure Administrator Associate or Azure Developer Associate exam and certification before taking the AZ400. The certification exam is mainly for DevOps professionals who streamline delivery by optimizing practices, improving communications and collaboration, and creating automation. They design and implement application code and infrastructure strategies that allow continuous integration, testing, delivery, monitoring, and feedback. DevOps professionals design and implement DevOps practices for version control, compliance, infrastructure as code, configuration management, build, release, and testing using Azure technologies. Microsoft Learn has excellent content on the AZ400 Learning Path series to help you prepare for the exam and obtain your DevOps Engineer Expert certification and badge. In my experience, the AZ400 exam is not fully development based. It is a great blend of development and operations and can definitely be taken by operation folks or Azure admins apart from developers. All right, that puts a wrap on my presentation. I hope it was of help. I believe you got a good head start into DevOps with the walkthrough here. I hope you enjoyed this session as much as I have putting it together. Do keep up with the ever-evolving technology landscape. I wish you the best of luck on your cloud journey. Thank you and happy learning.